Hello and welcome to helpyourmath.com. In this video, we're going to solve higher degree polynomial equations by factoring. So what that means is we're going to have our factors. We're going to have x minus a, x minus b, blah, 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 equals 0. And then we set each factor equal to 0 and solve. Let's look at some examples. In our first example, we want to solve by factoring. So we have x to the fourth minus 81x squared equals 0. Okay, what I notice here is that the two terms have a greatest common factor of x squared. So the first thing I'm going to do is factor out the GCF of x squared. That's going to leave me with x squared minus 81 equals 0. And now, before I set, well, it's up to you if you want to set each one equal to 0 now, or you might look at this and be like, wait a minute, I recognize that. That's a difference of squares. So you might want to go ahead and factor again. This will factor into x minus 9 times x plus 9 is equal to 0. Now we're going to set all the factors equal to 0, so x squared equals 0, indicating to us that x must be 0. If you're not sure about that, you can take the square root of both sides. If you take the positive or negative of 0, the square root of 0 is going to be 0. So we have one solution, 0. Then here, we're going to say x minus 9 could be 0, in which case x is equal to 9 when we add 9 to both sides. Here, we get x plus 9 is equal to 0. Subtract 9 from both sides and we get minus 9. So this example, we have three solutions. One is minus 9, one is 0, and one is 9. And do you know how many solutions we could have had, possibly? Look at the highest degree. That highest degree is 4. So there could have been a total of 4 solutions, but because we had that x squared, that took care of kind of 2 of them. So we had a double root, it's called. So that was 1, and that's why we only end up with 3, because of that double root of the x squared. Okay, what about this example? If you feel up for it, pause the video and try it on your own. Did you notice there was a GCF again? Yeah, there was. It was 5x, and it still is 5x. So we're going to factor out the 5x. That's going to leave me with x squared minus 16 is equal to 0. And then x squared minus 16, does that kind of look like something? Yeah, that's a difference of squares. That's going to factor into x minus 4 times x plus 4. Now we're going to set each factor equal to 0. This we're just going to kind of lump together because 5 can't be 0, so we might as well just leave it with x. So 5x equals 0. You can divide both sides by 5, but because of the 0 factor property, it has to be 0. X has to be 0. Then here we have x minus 4 is equal to 0. Add 4 to both sides and we get x equals 4. And then here we have x plus 4 is equal to 0. Subtract 4 from both sides and we get x equals negative 4. In this case, we had 3 solutions. Do you know what the maximum number of solutions were? There was a maximum of 3 solutions, right? Because the largest exponent was 3. We maxed out. We had as many solutions as were humanly possible for an example of this kind. All right, again, if you want to try this one on your own, go ahead. Otherwise, I'll go through it. So this one's a little bit different. We don't have a GCF among all 4 terms, but wait, there's 4 terms. When there's 4 terms, we can check to see if it's factorable by grouping. So let's see. We kind of hope it is because otherwise we're in real big trouble. When we factor by grouping, each grouping we pull out the GCF. So x cubed minus 6x squared has a GCF of x squared, leaving behind an x minus 6. In the second grouping, 2x minus 12, there's a GCF of 2, leaving behind an x minus 6. So now we have x squared times x minus 6 plus 2 times x minus 6 equals 0. Do the two terms, so this is term 1 and this is term 2, do those have something in common? Yes, they do. They have an x minus 6 in common. So we pull out the GCF and then we multiply it to the leftovers. X squared plus 2 is equal to 0. Now we can factor each one. This one, it's tempting to want to factor, but unfortunately 2 is not a perfect square, so we have a little bit more work ahead of us. So this one would become x minus 6 equals 0, which means x is equal to 6. This one we have x squared plus 2 is equal to 0. So then we get x squared is equal to negative 2. I'm going to take it up here. To get x by itself, we'll need to take the square root of both sides. Now we have a little issue here. We have a negative 2 under the radical. So that indicates to us that this is a non-real solution. I'll go ahead and deal with that. If you do get there, then we would only have one real solution, and that one real solution is 6. this is going to lead us to imaginary numbers. So we have x is equal to positive or negative. The square root of negative 2 we can factor out in I, because I is the square root of negative 1. And then what we're left with under the radical is 2. So this particular polynomial ends up having 3 solutions. One real solution, which is 6, and 2 imaginary solutions. One of the imaginary solutions is negative I radical 2, and the other is positive I radical 2. This one had 3 solutions, and that was the most that it could possibly have because the largest degree in the given polynomial was degree 3. In our last example, I suggest pause the video, see if you can do it on your own. Okay, what do we see about this one? I see that we have a GCF again. It's 4x, so I'm going to factor out 4x. That's going to give me x squared minus 5x minus 6 is equal to 0. Now we want to factor the trinomial, so x squared minus 5x minus 6. The target product is negative 6. The target sum is negative 5. Two things that multiply to negative 6 and add up to negative 5. You have to be careful here because 3 and 2 add up to 5, or negative 3 and negative 2 add up to 5, but they don't multiply to negative 6, they multiply to positive 6. So don't be thrown off by the 2, 3. It's not 2, 3, it's going to be negative 6 and positive 1. So this will factor into x minus 6 and x plus 1. Now we're going to set each factor equal to 0. This is 4x equals 0, therefore x equals 0. This one is x minus 6 equals 0, add 6 to both sides and we get x equals 6. And our last factor, we have x plus 1 is equal to 0, subtract 1 from both sides and we get negative 1. So our 3 answers, putting them in order from least to greatest, we have negative 1, 0, and 6. What was the maximum number of answers we could have? The maximum was 3. We found 3. Yay! Go us! These have been examples of solving higher degree polynomials by factoring. Thank you for stopping by.